All right, here on the 2.9 Go, we're actually going to do the sections of these first 6 problems that are pretty straightforward and fast. And then we're going to go back and do the x-intercepts that take a little bit longer and talk about that. So when it's in this vertex form, check it out. Remember that my vertex is staring at me here with my h and here with my k. So what I mean by that is my vertex is just -2, -4, where this number in front is my h, and this number at the back is our k. All right, so vertex, nice and easy in vertex form to get. Stretch is just the invisible number out front. See, it's a 1. Y-intercept is when x is 0. So we're literally going to plug in 0 plus 2 squared minus 4. So 2 squared is just 4 minus 4, which happens to be 0. So in this case, the y-intercept turns out to be through the origin, 0, 0. Now we're going to save the intercepts on all 6 of these for later, and I'll explain in just a second. Okay, pause the video, go get those other 3 pieces of information, which are pretty quick on each. All right, did you get that? Stretch of 3, y-intercept means plug in 0. Here we go, 6 squared first, which is 36. 36 times 3 is -108. -108 plus 3 is -105. Check me on that math, please. All right, vertex of this one, stretch of this one, y-intercept. Here we're going to do -1 squared first, which is 1. 1 times 2, which is 2. And then 2 minus 8, which is -6. So my y-intercept is -6. Down here, my vertex is -2, -64. Stretch is 4. Y-intercept, plug in 0. 0 plus 2 is 2. 2 squared is 4. 4 times 4 is 16. 16 minus 64, is that 48? Yeah. And that is -60. So it's -48. Okay, saving those x-intercepts. Next is 248. Stretch of 3. Y-intercept is when x is 0. All right, so this gives me -2 squared, which is 4. 4 times -3 is -12. -12 plus 48 is 36. And vertex is -6. Stretch is 1. Y-intercept is when x is 0. 6 squared is 36. 36 minus 1 is 35. Okay, so getting those 3 pieces, not too bad, right? But to get the x-intercepts, a couple different options. I could stretch this out into standard form, and we're going to actually use numbers 23, 24, and 25 as an example because that's what goes down here. It's telling you that numbers 23, 24, and 25 are actually the same as problems 11, 12, and 13. And down here it asks you to prove that. So what I'm going to do is take problem 23 right now and stretch it out and show you how we could work backwards to get the other thing. So I take this 4 and save it for later. I stretch out the x plus 2 squared that we're about to FOIL or do the box method, and then save this -64 as well. So x times x, x times 2, 2 times x, 2 times 2. That gives us x squared plus 4x plus 4. Then this 4 that's out front distributes. And then finally, 16 minus 64 is just negative 48. Now, we went from vertex form into standard form. Now I'm asking you to factor this. Well, factor means take out a, oops, forgot the x, take out a greatest common factor here. If 4 goes out, it ends up like that. And remember, our ultimate goal is to prove this here. I'm getting closer. What times what equals 12 and subtracts to give us 4? Well, that could be 6 and 2 with a negative here. So I'm getting 4. Oops, I want to switch those around because I want positive 4. 4x plus 6 and x minus 2 would be my factored form. So check this out. I went from vertex form to standard form to factored form. Yikes. But now I just proved that these two are equal. I started with this guy right here and ended up with this guy down here. Now, why did we do that? So that we could get the x-intercepts. So the x-intercepts of this graph would be at negative 6, 0 and 2, 0. I'm going back up here to problem number 23, negative 6, 0 and 2, 0. Next, I want the x-intercepts of this one. Number 24 is telling me that it's the same as the page before as well. So I'm about to erase all this work and then do the work for letter B, or number 24, down here as well. Okay, so this time I'm stretching this guy out. The x minus 2 squared factors, I'm going to FOIL these. X squared minus 2x plus 4. And then I get x squared minus 4x plus 4. We're then going to distribute this negative 3 to the whole thing. And I get negative 3x squared plus 12x minus 12. And then I add the constant. And I get negative 3x squared plus 12x plus 36. So I just spent all that time going from this vertex form right up here all the way to this standard form. And now I want to go to factored form. So I take out a greatest common factor, and I can keep factoring from there. And then I'm going to say what times what equals 12 and subtracts to give me 4. Well, it's a 6 and a 2 again. And this time this gets the negative. So my greatest common factor goes out front, x minus 6, x plus 2. And so again, I've taken this standard form right here and turned it into factored form. Why did I do that again? Because my goal here on number 24 was to get these x-intercepts. So now I know that it's at positive 6 and negative 2. But yikes, that was a lot of work. Finally, they're telling us that part C could be simplified to look like that, and that's number 25. So here I go stretching it out, x plus 6 squared. Don't forget that minus 1 later. I get x squared plus 6x plus 6x plus 36, which is x squared plus 12x plus 35. I then convert that to factored form, and I get x plus 5, x plus 7. That means, why did I get that down to factored form again? That these are my x-intercepts, the opposite of these factors. So negative 5, 0 and negative 7, 0 are my x-intercepts. Okay, so Going back up to numbers 20, 21, and 22, you could do a similar method to get those x-intercepts. I'm going to save those for in class with you guys. I know this was a pretty long assignment, and so I'm wondering how many people actually did this on their own and really attempted it. So I think I'd like to save all those part Bs up there for in class. Okay? Great job if you really did attempt this far on your own.